This is New Amsterdam Vape, and in today's tutorial, I will introduce you to Ohm's Law and how it's used for rebuildable atomizers in your vaping device. Ohm's Law is a very important concept to understand when you want to use mechanical vaping devices, which are basically batteries connected directly to an atomizer. You can build coils for the atomizer, which gives you more control over your vaping experience. These are unregulated devices, which means there is no chip that regulates how much power is being used, and can potentially be dangerous if used incorrectly. That's why Ohm's Law is very important to understand when starting to use mechanical mods. There are three different equations that are used that represent Ohm's Law. Each one of these equations only require two of these variables. The equation we will be using today is I equals V divided by R. I is the current, which is the rate of the flow of the electrons. The electrons are what makes up the electricity. This is measured in amperes. 1 ampere equals 1000 milliamperes. 1 amp equals 1 coulomb per second. This is a measurement of recording in 1 second how many electrons are passing a specific point. A higher current or high amperage means there are more electrons flowing per second past a certain point. A low amperage means there are less electrons flowing per second past a specific point. V is voltage, which is shorthand for voltage difference. This is the difference in electrical potential between 2 points. Another way of thinking about it is to think of the electrons. Each of the electrons inside the battery have a negative charge, so they all repel one another. With all the electrons pushing each other away, there's a pressure created inside the battery. When there's a closed loop or circuit connected to the battery, the pressure in the battery pushes the electrons from the negative to the positive. The voltage is what creates the current. R is the resistance, which is represented by the omega symbol. This is the ability for a material to restrict the flow of electrons through it. A higher resistance material restricts the flow of electrons, while a lower resistance material allows more electrons to flow freely. Here you can see different gauge Canthal wires. The higher the gauge number, the smaller the diameter of the wire. The lower the gauge number, the larger the diameter of the wire. The larger diameter wires have a lower resistance, since there is more room for the electrons to flow through. The smaller diameter wires have a higher resistance, since there is less room for electrons to flow through. Now that you understand the different variables, let's try a little math to calculate the amperage of different resistance coils. Here is a circuit with a battery at 3.7 volts and a coil with a resistance of 1.5 ohms. In order to find the amperage, we simply divide the voltage by the resistance. Dividing 3.7 by 1.5 will give us 2.47 amps. This is the rate at which the electrons flow through the circuit and back into the battery. Now when we change the resistance of the coil to 0.5 ohms, let's see how it affects the current. By dividing the voltage, which is 3.7, by the resistance, which is 0.5, we get 7.4 amps. This is a higher flow of electrons through the circuit as demonstrated in the graphic. By dropping the resistance of the coil by 1 ohm, we have almost tripled the amperage. There's one more important variable at work, which is power. This is expressed in watts or wattage. It's the process in which electrical current releases heat. And this heat is what turns your e-liquid into vapor in your vaping device. There are three different ways to calculate wattage. Today, I'll use the formula that only requires the voltage and resistance. Power is equal to voltage squared divided by resistance. Using the same 1.5 ohm coil from before, we'll calculate the wattage of this circuit. First, we square the voltage, so multiply 3.7 by 3.7, which will give us 13.69. Then we divide 13.69 by the resistance, which is 1.5. This will give us a wattage of 9.13. This is a measurement of how much heat is given off by this coil at this resistance. Now if we change the resistance of the coil to 0.5 ohms, let's see how it affects the wattage. We square the voltage again, which is 13.69. Then we divide this by the resistance, which is now 0.5 ohms. This gives us a wattage of 27.38. By reducing the resistance of the coil by 1 ohm, the wattage is increased 3 times, which gives us 3 times the heat. That means that lower resistance coils give off much more heat than higher resistance coils. This is how you can regulate how much heat you'd like to apply to your e-liquid, changing how warm or cool your vapor is. Here's a breakdown of 5 different coils that I made. Each one was built on the same 5/64 inch screwdriver, so they're all the same diameter, and they were each wrapped around the screwdriver 7 times. You can see the difference in the size of the coils. The coils that are of a larger gauge number have a much higher resistance, but lower amperage and wattage. The coils with a smaller gauge number have a lower resistance, but higher amperage and wattage. This helps you pick what gauge wire you want to use in your builds. If you want a cooler vape, then use a higher gauge wire with a higher resistance coil. If you want a warmer vape, use a lower gauge wire with a lower resistance coil. So remember, the higher the resistance, the lower the wattage and amperage, and the cooler your vape will be. The lower the resistance, the higher the wattage and amperage, and the hotter your vape will be. When you start building coils, aim for higher resistance coils while you're practicing your coil making. As you feel more comfortable with making your coils, experiment with lower resistance coils, but always make sure not to exceed the amperage rating of your battery. Ohm's law is a very important concept to understand because it helps you operate your battery safely without causing any damage or danger. Here's 2 batteries that I use frequently. The 18650 EFES battery has an amperage rating of 35 amps. The 18350 battery has an amperage rating of 6 amps. It's extremely important to know the amperage rating of your battery before you start building coils. If you exceed the amperage rating, you can do damage to your battery and cause it to vent. This means that the battery will start to heat up rapidly. As that heat builds, it can cause fire, and the battery can potentially explode inside of your mod. This is a very serious issue when new vapors start building coils without understanding Ohm's law and do not use an ohm reader. If your build is too high in wattage, the heat from the coil can burn you severely and cause the battery to overheat. You should always use an ohm reader when building coils. I will be going more in depth into battery safety in another video. While it's important to understand Ohm's law, it's not necessary to memorize it because there are calculators available online to help you calculate resistance, amperage, and wattage. The steam engine calculator is one of many calculators available out there that you can use. I'll provide a link in the description below. This has been New Amsterdam Vape, and if you found this tutorial helpful, please like, comment, and subscribe.